Good day, everyone. My name is Ravindra Keshamurthy, and I'll be presenting our project Mass Personalization Software Development for a coffee subscription company called Roasted Bean Box. Today, along with my teammates Karan Singh, Rishabh Jain, and Sudesh Nayak. So, as the presentation progresses, we will introduce you to our project in detail, explaining the company's current process flow with which they are operating, and then identify a few problems and drawbacks with the current process flow. Then, moving forward, we will talk about the entire process that we developed to solve the problems, which includes creating a database, building a recommendation system, and creating the visualization. Now, let's move on to our next slide for introduction. As mentioned earlier, Roasted Bean Box is a coffee subscription company which currently operates its entire process manually, with their data stored in multiple locations, making it difficult to retrieve and work on it. So, the primary goal of this project was to design and implement the automation of the activity entirely from the beginning. So, that is from the point at which the data is first stored to the final automated results that will be more reliable and cost effective. Now, let's move on to the current process flow which the company is following. So, in the company's current process flow, whenever a new customer signs up for the coffee subscription through a website, their data along with their taste preferences are stored in a Shopify website. Shopify is an e-commerce platform that enables anyone to create online store and market their products. So then through JavaScript, they extract the customer data from Shopify and as well as the coffee ratings into a Google Sheet. Then the company has a separate local CSV file with their attribute values of coffee aroma. Then in Airtable, they contain the details of coffee along with the customer data, which are stored together in a single file. From there, they allocate coffee to the customer based on their taste preferences and coffee data manually. Now, let's move on to the problem identification. So, after thoroughly reviewing the company's current process flow and collaborating with them, we determined that there are three major issues that required changes. So, firstly, it was a data storing process. So, currently, their data is dispersed and difficult to manage, which may lead to more errors. Secondly, the coffee was chosen manually, so which is working fine now, but as their customer base grows, this manual process will become more complex and time consuming with a higher risk of error, potentially leading to a loss of their customer base. Last but not least, the companies uses a single graph to show customers their aroma preferences, which is neither user friendly or interactive. Instead, we have developed an interactive dashboard that displays the customer journey with them. Now, Sudeshna will take over the presentation.
So, the implementation is done in three stages. First, we have created a centralized database in MySQL Workbench. Here, we store the customer, order, and coffee details, which are used to build the recommendation system in stage 2. As the company's requirement is to identify the customer's coffee preferences and also suggest coffees for them for the following months, therefore, we have built a recommendation system. This will help automate the current process of manually assigning the coffees to each customer. It will automatically recommend most similar coffees as per the customer's taste and aroma preferences. And in stage 3, we have built a dashboard for individual customers' taste and aroma so that they have a very clear visibility on their preferences. So first we have created a database to manage all the scattered data. To do this, we have used MySQL Workbench. As you can see here, coffee, customer and order tables contains the actual data, and these were joined to create coffee order and customer coffee profile tables as per the requirement for the recommender system and dashboard. So, why MySQL Workbench? It's because it has versions for all operating systems, has immense potential to do other RDBMS work, such as creating an entity relation diagram, etc. It is very user friendly and SQL is easier compared to other languages. Last but not the least, the interaction with server is very fast. There are certain limitations as well. It is server based and not cloud based. The commercial versions are chargeable. It supports only MySQL and MariaDB and subjected to crashing at times as well. These limitations, however, are not a concern as the company has very less data as of now, and therefore the advantages outgrows the limitations.
So after building a database server in MySQL, we connect a server with Python. Now Python provides us with various tools to perform our operations that we need to build our recommendation system with. And it is a very user-friendly and inexpensive language. So therefore we build a system with Python. Now just a one-line code connects us to a database from MySQL. And from there we fetch the coffee and the coffee order table. So from the coffee order table, we create a user item rating sparse matrix. Now this matrix gives us a lot of zeros, a lot of null values. The system reads those null values as a very harsh rating, which is not true because these values represent that the customer has not rated the coffees yet. So to overcome this problem, we create another matrix known as a relative matrix, which is derived from the mean of the ratings divided by the range. So in the figure B, you can see there are no zeros anymore, and the system would read those zeros properly as we require it to. Next, we use cosine similarity metric to determine how similar each coffee is with the another coffee. Now we have a certain parameters related to taste and the aromas of the coffee that the system uses to derive this similarity. Using all these system, we then move ahead to build our model. So a model uses the cosine similarity of the coffees as well as the user item relative matrix to calculate and return a few recommendations for the intended user. For example, if the user has previously given a rating of 1 to the coffee number 8, we would put that in a defined model as shown in the figure over here. Print get similar coffees 8, 1. The system would then work out its math and return us with a few recommendations for the next one for that user. Now the system has the ability to consider the object or the item quality or defect when proposing us the new objects in the item, thus preventing the inadequate suggestions and recommendations. Also, the system does not require much domain expertise and is very inexpensive. Now we do have a certain limitations with recommendation system, namely the synonymity and the cold start issue. And also every item must either be evaluated by other users or connected with other comparable things, otherwise it would not get recommended.
Stage 3 of the process, that is building an interactive dashboard in Power BI Desktop. So we started our dashboard by connecting the SQL server so the client won't have to update dashboard separately. We started by updating the relational schema first. Usually Power BI automatically creates relational schema, but for our dashboard we need to update relations and cardinality between data sets. After then we created measures to visualize aroma and taste preferences for the customer. But before that, we unpivoted few columns in ARP4 dataset using Power Query to create the measure for aroma and taste preferences, that is attribute and attribute 1 here in the ARP4 table. We used SumOver method using SumX function index and pre-aggregated the values. This is the new proposed dashboard which has been approved by client. In this dashboard, along with aroma preferences, customer can also see their taste preferences. With this Power BI dashboard, they will have more options to go creative whenever they want. They can change graph type or use more fields to display as per their needs. They will be saving a lots of time because now they don't have to calculate neither aroma nor taste preferences each time whenever customer places a new order, because all the measures have been already saved in Power BI file. Our goal was to make the whole process automated, and it is safe to say now that we did achieve our goal. Now they don't have to maintain their data at so many different places or choose a copy for customer manually. We have delivered SQL queries which will create the database structure, and now they all have to do is just insert new values into the tables. Recommendation system which we are using to choose coffee for a customer is in Python file. They just have to insert their SQL credential in that file. From the table over here, they will be able to identify customer orders detail, and in the end they can insert value in this query and algorithm will show the recommendation.